and welcome to Unit 3, Trigonomic Functions. This is Part 3 of graphs of sine and cosine. So again, a pretty thick lesson here with lots of different little things going on. But here's where we kind of left off. So we were looking at these two functions, sine on the left and cosine on the right. And we now understand that they are these cyclic oscillating functions. And they just kind of keep bouncing back and forth between 1 and -1. And again, one full period is one wave of the sine curve, and one full period is one wave of the cosine curve. So we kind of get this feel for these pictures. And we understand the period length, but it's one trip around that unit circle is 2 pi. And the amplitude is half of the total height, which is the distance from the midline to the top of the wave or bottom of the wave, okay? And typically it's 1. And then the midline is actually the x-axis, or y = 0. That's the line that we travel around. And we talked about the 5 key points, right? And again, if you think about that unit circle, that's our guide that helps us create these functions. We think about that unit circle. This is point 1. It's where we start at 0 radians, point 2, point 3, point 4, and the 5th point is actually back to the first point. So it's technically the same spot, same coterminal angle, but it is, again, we are continuing to move. So 2 pi would be the ending point there. So those are my 5 points. And sine's this nice curve that starts at 0, 0. So the y coordinate on the unit circle starts at 0, and then it slowly goes up until it reaches its max at 1 at pi over 2, comes back down to 0, back down to -1, it's min, and then back to 2 pi. So there's that full circle where cosine actually starts up at 1. The first x coordinate, 0 radians, is 1. And then we come all the way down to -1 and then back up to +1. So there's one full cycle. So what we want to talk about now is how these parent functions of sine and cosine can be changed. And it really has to do with changing the amplitude, changing the period, and changing the midline. So there's 2 ways that we're going to look at this in this video. We're going to look at some graphs, and we're going to see how could we see these changes in the graph. And that's actually pretty easy, and we'll go through a couple examples. But then we want to look at how could we see these changes in the actual function. So let's look at some graphs first. So here's a graph, and we want to try to figure out what's going on here. So first off, I like to find the midline first. You don't have to, but I'm just trying to give you my recommendation. And the midline is, again, that halfway point. So if we see that the max is 4 and the min is -4, half of that is 0. -4 plus 4 is 0. Half of 0 is 0. So we see we still have that midline at y = 0. Now, from there, we see the amplitude, right? The amplitude is half of the overall distance. So from 4 to -4 is a total distance of 8. So half that's 4, or you could also see the height of the hump, or the length of the trough or valley there, right? So the amplitude, now amplitude is always a distance, so it's always a positive number, so it's 4. And the other thing is the period length, right? So what we have to do now is say, where do we see one full period? And we got to remember that if we go back here just very briefly, that sine starts at that midline. It starts on the midline, goes up to its max, back to the midline, down to its min, back to the midline. Where cosine starts above the midline. It starts at its max, goes to the midline, to its min, to the midline, back to the max. So if I'm looking at this graph, and I guess I need to figure out, is this sine or cosine? Well, again, once you kind of know that midline, I'm going to highlight the midline in red there, we see that the graph starts above the midline. So that's a sign that this is a cosine graph. And we start at that midline, and then, we start above that midline at 4. We drop to the midline, drop to the min, come back to the midline, back to the max. So there's my period length, and now all I got to do is look, what is that period length? 4 pi. So the length of the period here is 4 pi. Normally it's 2 pi, but it's obviously got spread out. So get a transformation. So you kind of think about what happened here. This got vertically stretched, that's that amplitude, and then it got horizontally stretched, that's the longer period length. Let's look at another one here. Again, I do recommend finding the midline first. I think it kind of makes other things fine. So the max is at 1, the min is at -1, so half of that is going to be my midline. So 1 plus -3 is -2, half of -2 is -1. and we can actually see the midline there. Most kids don't necessarily do math work. They just kind of eyeball it. They're looking for that halfway. So where we see that amplitude is 2 now. So it's up 2 here, down 2 here. So first off, we see the midline has moved down to -1, and the amplitude is 2. The height of the valleys and the height of the humps are 2, right? Or again, you could look at amplitude as the overall distance from 1 to -3 is an overall distance of 4. Half of 4 is 2. And then now what about the period length? So once again, we got to say, okay, remember sine starts on the midline, cosine starts above it. So if we look, where does this graph start? It starts right here on the midline. Even though the midline got moved down, I'm still starting on that midline. And then sine goes up to its max, back to the midline, down to its min, back to the midline. So I recognize that this is sine because I see that full period there. And again, I started at the midline. And then again, so what I'm seeing now is that one full period, it took 6 pi. So the period length, which again is normally 2 pi, the period length is 6 pi. So we're just identifying these 3 really, really key features. And let's look at another one here. So once again, I want to find my midline first. So I'm thinking the top here is 7. The bottom here is 3. So 3 and 7 is 10. Half of 10 is 5. So we see we have that midline right here at 5. And my y-axis was labeled every 2 units. So in between 4 and 6 is 5. And then once you draw the midline in, then you realize, yeah, amplitude up 2, down 2, up 2, down 2. So we see the midline is at y equals 5. And now we clearly see that amplitude is 2. Now it's all about where's the period length. Well, again, we got to first recognize, is this sine or cosine? That's where I said, well, where did it start? It started above the midline. And it went down to the midline, down to its min, back to the midline, back to its max. So that is, of course, a cosine curve. And now I realize that the total period to make that one cycle, that one wave, was a period length of 3 pi. So hopefully that makes sense. So now that we kind of understand what these changes to the amplitude, the period, and the midline look like graphically, let's talk about what they look like actually looking at the function. So we have the 2 parent functions. The parent functions start out as sine of x, just generically sine of x, and cosine of x. And remember, way long ago, we did a lesson on parent functions where we say, okay, like, for example, the parent function for a parabola is just x squared. And then we take that x squared and we move it, right? And that's, again, where the transformations come in. So we have 3 different types of transformations. And again, this is the period length, the amplitude, the midline. So we have A multiplied out in front of the sine or out in front of the cosine. We have B multiplied inside of the sine or inside of the cosine. And then we have a D added or subtracted on the outside. So all 3 of those features correspond to the period, the amplitude, and the midline. So first off, let's start with the midline. Again, I do like to start with the midline. So the midline is simply your D value, right? Traditionally, sine has a D value of 0 because it's just sine plus 0. Well, obviously, we don't write the 0, but where this is a vertical slide, right? This is just a translation up or a translation down. So if you think about that midline and we move it up 5, well, now the midline's at 5. If we go down 6, well, now the midline's at -6. That D value is where your midline is. The amplitude is out in front. Remember, when you multiply out in front of a function, when you multiply outside of a function, that's a vertical stretch or shrink. So if our amplitude, traditionally there's a 1 right here, which is why our amplitude for the parent function is 1. But if we throw a 2 out in front, that's what's going to stretch us to 2 for an amplitude, up 2, down 2. Remember, the overall distance will now be 4. Or we can even make that amplitude small. Like we could put a 1/4 out in front. And that's going to really vertically shrink us. So now my max is 1/4 and my min is -1/4. So that's a much vertically shrunken graph there. And then now the period length is the one that's not so obvious. You do have to do a little bit of math work here. But the period length is found by taking 2 pi divided by the b value. So you take that b value, that is what's being multiplied by x. So whatever's being multiplied by x, and you do 2 pi divided by that. Again, traditionally, there's just a 1 in front of that x, and 2 pi divided by 1 is 2 pi. That's why the traditional period length is 2 pi. But when you multiply by a value inside, it does cause that period to change. We could also reflect across the x-axis. Now remember, reflecting across the x-axis is a negative out in front. So if we put a negative out in front of the value, now it looks like it's a negative a, but remember amplitude is always positive. That's why I put absolute values around it, because amplitude is a distance. So if there's a negative on that a, that doesn't affect the amplitude. What that does is that just reflects you. So again, if you think about sine traditionally starting by going up and then down and then back to the midline, if I reflect sine, then it goes down first, up, and then back to that midline. Same thing for cosine. Cosine starts at above the midline, drops, and comes back up. Whereas if I reflect it, now it starts below the midline, goes up, and back down. So that's that reflection across the x-axis, which is a negative out in front. We can reflect across the y-axis, but we don't. Honestly, we're just not going to deal with it in this lesson. But that would be a negative inside the function. But here's why those are kind of weird, is because remember, these curves go on and on and on and on and on forever. So if you reflect one side to the other, then the other side comes to the other, and the graph really doesn't look much different. It does happen, but to be honest, in this video, we're just not going to deal with it. All right, so what we want to do now is, like, we just got done looking at graphs and identifying these three key features, which I hope you agreed was pretty easy looking at graphs. But now let's actually look at some functions, not the graphs, and then identify the features. And then we actually will take a look at the graphs in Desmos. So first off, if I'm looking at this function, I want to really identify the midline, the amplitude, and the period length. These are the really important things you got to identify. So first off, the graph is clearly getting slid up 5. So we have that traditional cosine graph that's going up 5. So it's pretty obvious. Midline is now at 5. The amplitude is the a out in front. So instead of going up 1, down 1, up 1, down 1, up to 1, down to -1, we're now stretching that to 4. So my amplitude is 4. And the period length is where, again, you got to do a little bit of work. So my b value is the multiplied value in front of the x. So again, the formula to find period is 2 pi divided by b. So 2 pi divided by 2. 2's cancel is just pi. So my period length is pi. So what I did was actually horizontally shrunk or squeezed my graph. So, if you think about 0 to 2 pi, so traditionally cosine takes that full wave from 0 to 2 pi. Now it's going to do that wave from 0 to pi. So from 0 to pi, it's going to make that wave. So there's actually going to be 2 waves within 2 pi, because every pi, it makes a wave instead of every 2 pi. So that's it. I mean, it's really easy. I mean, it shouldn't be really that difficult at all. Hopefully it's pretty common sense there. So let's actually take a look at the graph of this so we can see it. So we see our midline at 5 here. And when your midline is at 5, and then we also see the amplitude of now 4. So the max is at 9 and the min is at 1. So we see if we're at that midline of 5, if we go up the amplitude, we're at 9, down the amplitude, we're at 1. So we see that total distance of 8 from the top to the bottom. Half of that is your amplitude 4. And then again, cosine, remember, starts above the midline. So that's why I'm starting above the midline. Cosine, one full wave, goes to the midline, comes down to the min, back to the midline, and then back to where it started. And we see that that one full period took place in pi, which means in 2 pi, we actually see 2 full periods. And then 3 pi, we see another period. So again, every pi, we would see a period. So we kind of horizontally squeeze that. All right, let's take a look at another one. This one is a little bit trickier, but again, it's not really any harder. So the first off, we see that midline went down 2. So we took the entire graph and slid it down 2. So the midline is now at y equals -2. The amplitude is the a value out in front. That's going to vertically stretch us to 2 now. So if we're thinking about that midline, the midline's the middle, and then we go up the amplitude for -2. That's going to take me to 0, and we go down to -4. So we're going to see this graph centered at a midline of -2, and then the amplitude goes up to 0, down to -4. And we'll look at a graph in a second to see that. Now, the period is what's a little bit tricky here, but if you just follow my formula, you can't go wrong. You're going to take 2 pi divided by my b value. Now, my b value is whatever I'm multiplying by x. I'm actually multiplying a lot here. I'm multiplying by 2 pi divided by 3. 2 pi over 3 is a number, so that is my entire b value. Some kids will just look at 2, or they'll just look at 2 pi. No, it's everything that's being multiplied by x. 2 pi divided by 3. So I do have to do a little bit of math here. I'm going to take that 2 pi, divide it by 2 pi over 3. And then, of course, I got to follow some algebra rules. Instead of dividing by a fraction, I'm going to multiply by the reciprocal, 3 over 2 pi. And something really awesome happens here. The 2's cancel, the pi's cancel, and my period is just 3. So this is really weird, but now what typically happens from 0 to 6.28, 2 pi, now happens from 0 to 3. So it's weird that your period is a whole number, but that's fine. That's totally okay. It's not anything for you to worry about. It's actually really easy. So now when I take a look at the graph here, we see this, right? So first off, we see the midline hovering here at -2. The amplitude goes up to 0, up 2, down to -4, down 2. And then again, this is cosine, which starts above the midline. And we see that down to the midline, down to the min, back to the midline, back up to the mix. All of that happens within exactly 3. So no longer is it 3 pi. Remember, the pi canceled. So the period happened at exactly 3. A unit of 3 units is where that one period happened. All right, let's take a look at a third example here. All right, so a lot going on here. Let's see here. First off, I noticed the midline is down 7. So the entire graph gets slide down 7. So that midline is now at -7. And this is going to be very, very short because my amplitude is 1/4. So my midline is down at -7, but from -7, I only go up a quarter and down a quarter. So my trig graph is really only 1/2 wide, right? The height is only 1/2, and then up 1/4, down 1/4. So it's very, 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 very squeezed, right? So it's going to be very, very tiny like that, right? All right, then I also need to figure out my period length. And again, you take 2 pi divided by that b value. The b value is 1/5, right? It's everything other than the x. So that's a good way of looking at it. So it's 2 pi divided by 1/5, which is obviously going to be 2 pi times the reciprocal, 5/1, which I get 10 pi. So this is horizontally stretched. Typically, sine occurs from 0 to 2 pi. Now it takes 0 to 10 pi to create this graph. So here's a look at it. And again, look how flat it is. It's very flat. You see the midline is here at -7. And from that midline, I only go up a quarter, very, very small amount. And I go down a quarter, very, very small amount. And look how drawn out this is. Again, one full period of sine starts at the midline, goes up to its max. Sorry, I can barely draw it. It's so flat. Down to its midline, down to its min, back to the midline. So very, very elongated because I stretch that period length out to 10 pi. Whew, okay, we're going to look at one more example. I know this is a lot, but looking at all these examples really does pay off. It truly does. All right, another problem here. We see clearly the +8 is going to change my midline. So my midline is now at y = 8. The whole graph went up 8. I see an amplitude of 7. So I'm thinking about from that midline of 8, I go up to 15, down to -1. And notice that there is a reflection. So this is a reflection across the x-axis because it's out in front. So again, traditionally sine goes up and then down and back to the midline. Well, now it's going to go down, up, back to the midline. So be ready for that when we look at the graph. All right, now we also got a period change here. So let's talk about the period. Again, 2 pi divided by whatever's not the x, right? So that's the pi/4. That's what we're multiplying x by. Pi/4. So we're going to take that 2 pi, we're going to multiply it by the reciprocal, 4/pi. Now this is actually pretty cool. The pi's cancel. 2 times 4 is 8. So my period is a solid 8. No pi here. And that's just what happens when the period, the pi cancels out. It's just something that happens with these graphs. So again, I'm trying to think ahead what this is going to look like. Midline's at 8. It goes up to 15, down to -1. And it's going to reflect. So it starts at the midline. Sine always starts at the midline. But instead of going up, it goes down because it got reflected. And then again, this is going to happen over the course of 0 to 8. So here's, of course, that beautiful graph. We see that midline here at 8. Kind of draw it in there. I'm sorry, I'm bad at drawing straight lines. And we see that it goes, the first movement, because that reflection, again, starts at the midline. First movement's down 7 to 1. Was I saying -1 earlier? I'm so sorry if I was. What a 8 minus 7 is 1. I think I was saying -1 earlier. Oh my gosh, sorry for that brain fart there. All right, so we go down to 1 and then up to 15, right? Because when we go that amplitude up, starting at midline of 8, up 7 is at 15. And then again, that one full period starts at the midline, goes down to the min, up to the midline. Now, because the reflection up to the max, back to the midline, there's one full cycle of this reflected sine. And again, that ends right here, which is the period of 8. So pretty cool, pretty easy, I think. So again, what do you need to be prepared for here is either I give you the graph, you tell me those 3 key features, period, amplitude, and midline, or I give you the function and you tell me those 3 key features. So those 3 key features are really important parts of all sine and cosine graphs. All right, so stay tuned for part 4. There's one more part where we kind of talk about one last transformations and look at a bunch of examples to really make sure all this sinks in.